Hey everyone, in previous lecture I discussed what is normalization. Normalization is simplification of relational schema based on some properties that it will be easy to insert, delete and modification. There are different type of normal form. Now we'll discuss first normal form. A relation schema can be in first normal form if every attributes are atomic. What is atomic? Atomic means it should not be divisible. It should not be composite. It should not be multi-valued or nested attribute. Then we can say it is a atomic attribute. A domain is atomic if elements of the domain are indivisible unit. We should not able to divide it. So you can say one relation schema is in 1NF if the domain of all attributes of R are atomic. A set of name is an example of non-atomic value. In name there is first name, middle name, last name. So it is non-atomic. We should not be able to divide it, but name we can divide as first name, last name. Even address is a non-atomic attribute. Okay, in address there is street name, city, state, zip. So that's why it is a non-atomic. Integer is a atomic domain. It should be either integer or alphabet. It should not be combined of both. In some company, ID number are combination of alphanumeric. Okay, means there are some alphabet for department and there are some number and that is non-atomic. For example, CS001. CS for computer science, 001 is the code. Then EE electrical engineering 1127. So these are combination of alphabet and numeric. So such type of identification are non-atomic. This cannot be atomic. As you can divide it into smaller units, so it is non-atomic. The table is said to be in 1NF if attributes are atomic and column name must be unique. Attribute name must be unique. It should not be repeated and that row and column value, each box should contain a single value. There should not be multi-value. Composite, multi-valued and nested attributes are not allowed. If every attributes are atomic, then that relation schema is in 1NF. Next we will discuss 2NF. For 2NF, first condition it should be in 1NF and there should not be any partial dependency. What is partial dependency? Suppose A, B combinedly are key, okay, then C should not depend only B or only A. That is a partial dependency. So in one relation, every attribute should depends on its key. If there is any partial dependency, we can separate that and we can make another relation for that. So a relation schema is in 2NF if it is in 1NF and free from partial dependency. If partial dependency exists, we can separate the table. Let's see one example that you can understand. So here we have some attributes like A, B, C, D, E, F, G, H, I, J and some functional dependency are given. Here all attributes are atomic. It's in 1NF. Now in 2NF we need to split the table, okay, according to dependency. C is dependent on AB, DE is dependent on A. So DE partially dependent. We cannot write A, B, C, DE in one table. A, DE should be separate. So for better understanding, we can make a tree-like structure like A, B, C. C is dependent on AB both, then D, E, they dependent on A, then F dependent on B, G, H that dependent on F, I, J that dependent on D. So what you can do, B, F, G, H one relation schema, A, D, E, I, J one relation schema, this A, B, C you can make another relation schema, okay. A, D, E, I, J that will be in one table, R1 for A, D, E, I, J, then R2 for B, F, G, H, R3 for A, B, C. Just mark in the first table D, E, I, J all dependent on A. In the second table F, G, H all dependent on B. In the third table C dependent on both A, B. So there are no partial dependency. Let's see another example. Example 2, we have a relation schema and some functional dependency. We need to find the second NF. Here F, C, they are dependent on A, D is dependent on C, E is dependent on B. That's it. There are just 3 functional dependency. So clearly we can make 2 relation schema, one for BE, another for A, F, C, D. We need to make a link between A and B. That's why we will make another table for A and B. Like R1 that contain A, C, D, F. Here C, D, F all are dependent on A. A is the primary key. Then in R2 is dependent on B. B is the primary key. Now another table that contain both table key, we can make relation between them. So we need 3 table, one for A, C, D, F, another for B, E, another for A, B. Now next example, example 3, E dependent on B, D dependent on C, B dependent on A. So clearly C, D will be in one table, A, B, E that will be in another table, and A, C that will be in third table. We are making key of both table in one table. In case of 3 and F, we are removing the transitive dependency. There we need to separate BE. Means E is dependent on B, B is dependent on A, so that is a transitive dependency. But now we are discussing second NF. In second NF, we are removing the partial dependency, not transitive dependency. So A, B, E will be in one table, C, D will be in one table, another table that will contain both table key. So A, C. Next example 4, we need to check 2 and F based on the functional dependency. Here C is dependent on AB, E, F both dependent on BD, then AD, GH, then A, I, H, J. So A, G, H, J, D that will be in one table. J is dependent on H, H is dependent on both AD, then A, I that will be in another table, B, D, E, F that will be in one table, A, B, C that will be in one table. So there are 4 separate table based on the partial dependency. Rather than that, there will be one more table that will contain the primary key of all table. So total there will be 5 table. R1, A, B, C. Here A, B is the key. R2, B, D, E, F, P, D are the key. Then R3, A, D, G, H, J. Here A, D are the key. Then R4, A, I, A is the key. So these are according to the division, according to partial dependency. Just mark how many keys are there. A, B, D. So we'll make separate table for A, B, D. That will contain all table primary key. That's all about 2 and F. In 2 and F, we are removing the partial dependency and every attribute should be atomic. Means it should be in 1 and F, then only you can check the 2 and F. In next lecture, I will discuss 3 and F. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.